Hello viewers, in today's session we are going to discuss another important and very conceptual problem from functional equations, right? And here we are going to discuss this problem, which is a mixed problem from differentiation and functional equations, right? So here we'll see the application of differentiation or the concept of differentiation in solving functional equations. So let us first read out this problem, and then we'll see how we can solve this problem with the help of derivatives, right? So here consider the function f from the set of real numbers to set of real numbers r to r, and this function f, it satisfies this equation f of x plus y minus f of x minus f of y is equal to xy minus 2 for all values of x and y belonging to the set of real numbers. And here we are given that this function f of x is differentiable, and the derivative of this function f of x at this point, that is x is equal to 0, that is f prime of 0 is equal to minus 3. Then we have to find the function f of x, right? So using this functional equation and some concepts from derivatives, let us see how we can find out the function f of x. So before solving this equation, let us quickly see the definition of derivative, because this definition is going to be of prime importance while solving this equation, right? Now see, the derivative of a function, say f of x, that is f prime of x, is defined by this limit, that is limit h tends to 0, f of x plus h minus f of x divided by h, right? So this definition of the derivative is sometimes also known as the first principle, right? And here h is infinitesimally very small, and remember h is a positive quantity, right? Okay, so now here if we take x is equal to 0, then we have f prime of 0, that is equal to a limit h tends to 0, f of 0 plus h minus f of 0, and then here we have h. So now f prime of 0 is given by this limit, that is limit h tends to 0, f of h minus f of 0 divided by h. So this limit is going to be very useful while solving this functional equation. So let us write the equation f of x plus y is equal to, let us take these two terms to the right hand side. So we have positive f of x, then here we have plus f of y, and then we have xy minus 2, right? So now this equation can be written like this, and let us substitute x is equal to 0 and y is equal to 0. So we have f of 0 plus 0, here we have f of 0, f of 0, and here x is 0 and y is 0, so this term is 0, and we have minus 2. So 0 plus 0 is 0, here we have f of 0, this is 2 times f of 0 and minus 2, taking 2f of 0 to the left hand side, we have minus 2 f of 0 is equal to minus 2. So we have minus f of 0 is equal to minus 2, because here we have 1 f of 0. So 1 minus 2 is minus 1. So minus and minus get cancelled. So here we have f of 0 is equal to 2. So this is the first important deduction which can be made by making this substitution, x is equal to 0 and y is equal to 0. So let us write f of 0 is equal to 2. Now if we take f of 0 is equal to 2 over here, then this limit takes the form that is limit h tends to 0, we have f of h minus 2 divided by h. Now we'll utilize this limit in further steps. So now let us once again come to the definition of the derivative. So here we have f prime of x, and this is limit h tends to 0. Now let us see this term. So here we have f of x plus h. Now x and h are both real numbers, so we can apply this equation to this term, that is f of x plus h. So replacing y by h in this expression, we can now write f of x plus h as f of x, and then we have f of h, and here we have xy, so this is xh minus 2, right? So now if we take this term to the left hand side, we have f of x plus h minus f of x is equal to f of h plus x of h minus 2. So now we can replace this entire term by this expression. So we have limit h tends to 0, f of h plus xh minus 2 divided by h, right? Okay, so now we can write here limit h tends to 0, and we can now write f of h minus 2. So we can combine these two terms, and here we have xh. Now distributing this h over this term and this term, we have limit h tends to 0, f of h minus 2 over h, plus limit h tends to 0, and we have xh over h, right? Now this h and this h get cancelled, so now we have simply x, and this term is independent of h, so we can omit this limit notation in the next step. So we have simply x, right? And here we have this limit. Now see, this limit, that is limit h tends to 0, f of h minus 2 divided by h, is given by f prime of 0. So here we have f prime of 0 for this limit, and here we have simply x, right? So now the derivative f prime of x is equal to f prime of 0 plus x. Now in the given problem, we are given that f prime of 0 is equal to minus 3. So let us substitute over here, f prime of 0 is equal to minus 3. So now f prime of x is equal to minus 3 plus x. So now the derivative of the function f of x, that is f prime of x, is equal to minus 3 plus x. So now this expression is a differential equation, that is f prime of x is equal to x minus 3. So here we have a linear function, and here the derivative of f of x. So this is a differential equation, and we can extract the function f of x by integrating both sides. So we can now write d by dx of f of x is equal to x minus 3. So now integrating both sides with respect to x, we can now write here x minus 3 dx, and we have to add a constant of integration, that is c. So now this expression is simply f of x, and here we have x square over 2, and here we have minus 3x, right? So the integral x dx is x square over 2, and the integral dx is simply x. So here we have plus c. So the function f of x is now a quadratic function, and x square over 2 minus 3x plus c. Now we can find out the value of this c by using the boundary condition or initial value condition. So now we have just calculated that f of 0 is equal to 2, right? So we can make use of this condition in finding out this constant of integration. So if we take x is equal to 0, then f of 0 is equal to 2. So here taking x is equal to 0, we have f of 0. Here we have 0 square over 2. Here we have minus 3 times 0 plus c. So this term is equal to 0. So we have 0 plus c, that is c. And f of 0 is equal to 2. So the value of c is equal to 2. So taking c is equal to 2, over here we have f of x is equal to x square over 2 minus 3x plus 2, right? So this is our required function which satisfies this functional equation, provided the condition, that is f of x is differentiable and f prime of 0 is given as minus 3, right? So this is how we can find out the form of the function f of x, and here we can conclude that this function is a quadratic function.